shear. What is shear? Shear is inclined surface. Suppose I can say, instead of flat ends pen, if you take as a ink pen which has increasing, suppose for example in diagram, applying force with this chalk and with the ink pen is like this shape. So apply force with this both on yours, any on any person, so the ink pen will enter easily and it can produce more pain. In the same way, because here area of contact starts with point and goes to line, but in the case of chalk, area of contact starts with surface. So more area of contact, you need more force. Less area of contact, you need less force. And because in less area of contact, it can easily penetrate. So a similar concept is applied here in punching also. Similarly, instead of flat surface punch, what we can do is we can incline the surface of the one end of the punch. So this inclination helps us to cut the operation very fast. This is called shear. I equal to shear. So in punching, shear is provided on punch. In punching, shear is provided on punch. In blanking, shear is provided on die. So objective of shear is to reduce the force required for operation. The more the shear, the less the force required. So how much is the optimum shear? The optimum shear is near equal to the thickness. If you go beyond that, there is a failure of the punch takes place. So what is the maximum, what is the force with shear? So for that, before this, work done without shear equal to work done with shear. Work done is nothing but we have discussed force into displacement without shear. So but if you use shear, F nu or Fs, force with shear, so Fs into K into plus I is extra travel shear, Fs is where Fs equal to force with shear. So whether you take shear on punch or whether you don't have shear on punch, you are doing same operation. So that's why work done is same. So by only the force will vary. Force with shear equal to force without shear by Kt plus I. So as you increase the denominator, the force required with shear is decreases. So from the above equation, as the shear increases, the force required decreases. As the shear increases, then the force required decreases. So that's a concept here. Second method is staggering of punches. So what is staggering? Is also called as progressive die forming. It is also called as progressive die forming. So in progressive die forming, performing multiple operations in one stroke at different stages. Performing multiple operations in one stroke at different stages. It's called progressive die forming. Just now we have discussed in simple punching operation, as we have drawn one diagram earlier. Only one operation was shown, that is called simple punching operation. Instead of that, there are two punches, so then it is called multiple punching operation, happens only in progressive die forming. So here this is die, and this one is punch, this is sheet, this is punch. Here you are applying F1, F2. Applying force required for F2 will complete both punching operations. So instead of applying F1 F2 separately, apply the force required for the higher punching operation, higher size. So that includes, because it is staggering, means the length of the punches are differ. Once the one new punch starts operation like cutting operation, the second punch will be already ended, or by the time first punch will complete the punching operation, then only second punch will start into punching operation. So it happens in fraction of seconds. So the both punch won't punch cutting operation takes place, they won't take place at a time, they will take place at the time lap of fraction of seconds, but in one stroke only. That's why here it is called staggering of punches. Again, in the punches you can provide shear to reduce the force. This is one method. Next, get question number 8. Force required in a blanking operation of low carbon steel is. So blanking force FB equal to 5 kilonewton. The thickness of the sheet and diameter of the blanked part is. Thickness of sheet T equal to, that is 3. Diameter of blanked part equal to D. For the same work material, means what? Same mechanical properties, same shear stress. The diameter of the blanked part is increased to D 1.5 D, and thickness is reduced to 0.4 T. New blanking force, we know that blanking force is a function of F2 equal to blanking force equal to stress into perimeter pi d into thickness, surface area, right? So F d2 into T2. So F2 equal to tau into d2 is substitute 1.5 d1 into T2 is 0.4 T. So tau into pi d1, instead of d1 I give d, pi d into pi d into thickness into 1.5 into 0.4, 0.6 into tau into pi dt. It's nothing but pi dt is f, 0.6 f. So how much is that fb, blanking force? F2 equal to 0.6 into 5, 3 kilonewton. Simple. 2 marks question. Anybody can solve this. So only thing is you need to know what is punching force upper formula, whether it is punching or it is blanking. Similarly, there is 4 mark question, not 2 marks, 4 marks. Linked answer. It's very important. 4 marks question, linked answer question. So in linked answer question, if question 1 correct, then only your question 2 is get validated. Question number 1 and 2. First we will complete 1. Date 2010. In a shear cutting operation, a sheet of 5 mm thickness. So thickness of sheet, whatever he has given in the problem, we will write first. Sheet T equal to 5 mm, cut along a length of 200 mm, length L. So L equal to how much? 200. The cutting blade is 400 mm long and 0 shear. Shear I equal to 0. Provided on the edge, the ultimate shear strength tau equal to 100 MPa. MPa is megapascal, Newton per mm square. Penetration to thickness ratio 0.2. Penetration to thickness ratio, nothing but percentage penetration instead of ratio of penetration to thickness ratio, equal to 0.2. Assume force versus displacement is, first question, force versus displacement is rectangle, that means it is, there is no shear, anyway shear is not 0, shear is 0 we have taken. Work done he is asking, force into displacement. Force is nothing but stress into what is the area? Perimeter, surface area into K into T. Tau into surface area is nothing but perimeter into thickness to K into T. Perimeter is length into thickness into K is 0.2 into thickness is 5. Substitute all values here, you will get work done equal to 100 joules. Simple. Second question, considering shear I equal to 20 mm for the same material, then force, if you apply shear, then force for displacement diagram will convert into trapezoidal from rectangle. Then force required equal to F into KT divided by KT plus I, we know the formula. Force with shear equal to F is 100 into K is 0.2 into I So now k into t is 5. 0.2 into 5 plus I is 20 is approximately 5 kilonewton. So if you know this concept, you can solve this in just 2 minutes, 4 marks. It's very easy, and the problems last time GATE 2012 also they asked the question in this. That's why this is a very important, is punching and blanking. They ask force required or work done, or the diameter of the punch, diameter of the die. Or next is deep drawing or cup drawing. So this is one of the manufacturing process where mostly utensils are manufactured. Producing cup shaped components from the thin sheets is called cup drawing or deep drawing. Manufacturing utensils. Here first of all we need to take the this is the initial diameter of the sheet. This is a side view. Top view is, it is occupies a lot of space. It's circular, but I have not shown it properly, sorry. So this one is diameter of the sheet, and here it is thickness of the sheet. D is diameter of the sheet. If we apply a load on it, if clearance between punch and die is more than equal to thickness of sheet, then the sheet can form a cup shaped component. So what it explains is, if the clearance between punch and die is nearly equal to thickness or more than the thickness, then it allows the sheet goes to bending operation instead of cutting operation. Deep drawing is, it is forming operation, where force or load applied produces stress more than yield stress, and less than ultimate stress. Okay, so objective is you want to bend, that's it. There has to be some deformation. It's not like failure, it's not like cutting. You want to create a cup shape of from the circular sheet. Vinyl sheet, you want to create a cup of diameter d and height of h. So for example, if you take this diagram, so here it is ideally values, the calculation is neglecting corner radius, neglecting corner radius. D is initial diameter of the sheet. Small d is diameter of cup formed. H is height of the cup. Volume of before and after remains same. Based on that, volume is area into thickness. Pi by 4 d square plus pi dh into thickness equal to pi by 4 d square into thickness. After simplifying, d equal to root of d square plus 4h. So very important for me. By neglecting corner radius, initial diameter required to produce a cup of diameter small d and thickness height h. Take GATE question number 17, GATE 2003. A shell of 100 mm diameter and 100 mm height with corner radius of 0.4 mm is to be produced by cup drawing. The required blank diameter is cup height, hundred mm, cup diameter, 100 mm, corner radius 0.4 mm, which is neglected, blank diameter need to calculate. Blank diameter capital D equal to square root of small d square plus 4d square h. Substitute the values, you will get 224 mm. Simple. Just 2 marks question. You can solve in 1 minute. Anybody can solve in 1 minute. So that's the beauty of this manufacturing. You can solve questions easily. They give only questions in exam. That's very advantageous compared to other subjects. In cup drawing, there are stresses induced in cup drawing. Stresses develop in cup drawing. So what type of stresses will develop in cup drawing?